All right, in this video, I want to develop the unit circle. Okay, so we're going to take a circle. I don't want that to be that thick. Try that again. Okay, so we're going to take a circle, and it's going to have a radius of 1 unit, okay? 1 unit. All right, so when you have a circle that has a radius of 1 unit, the measure of the central angle, so let's say we have an angle right here, then the measure of that central angle, which would be this guy right here, in radians, would wind up being exactly the same as the length of this right here, which is the intercepted arc. And the reason for that is, if you remember, the length of the intercepted arc is supposed to be the radius times theta, where theta is in radians. Okay. And so S would equal 1 times theta in radians. So S and theta are really the same thing if you're on the unit circle. Right? Another way to think about it might actually make more sense to you is to actually think about theta in radians being defined. So if theta is in radians, being defined as the length of the arc in terms of how many radiuses it is. So whatever the length of the arc is divided by r. So you see, if the radius is 1, then theta is the same as the length of the arc. Okay. All right, now here's what's happening. We're just trying to transition from having to think of the trig values of angles to being able to do the trig value of any number. So we can do that. Okay. So what this statement is saying is that we're going to call this right here, this length is going to be t. Okay. And the point xy, the point P, which has coordinates xy, is going to be the location of that point. Okay. So you don't really have to think about the terminal side or think of things in terms of an angle. We're going to then talk about the sine, the cosine, and the tangent of this real number t. Okay. But we're going to work it out pretty much like we did when we had the point xy earlier, and we had this right here being the radius of the circle. It's just now it's a radius of 1. So sine was defined to be y over r, but r is 1. So sine is going to be the y coordinate of that point. Cosine is x over r is 1. So the cosine of t would just be x, and then tangent would be y over x, just like it always was. Okay. So when you're looking at that, really think about it. That means this point right here that was xy is really cosine of t, sine of t, because cosine t is x and sine t is y. Okay. So what I want to do in this video is work on developing the unit circle, thinking about how to create it. Okay. And so one of the things you need to know is what the sine and cosine for the special angles are, because that's what you're showing on this circle. Do you notice how I'm showing the 30, the 45, and the 60? And I went ahead and just put all of those on there because you could have located all of those and written down what this location was in both radians and degrees. You actually did that in an earlier notes page. Okay. So right now we're focusing on this. We're going to try to figure out what the coordinates of these points would be all the way around the unit circle. We want to know what the coordinates of all these points are. So these are like the point P. Okay. And so we want to know what the x and the y coordinates are. Now, if we know the x and y coordinates of these, then we also know the cosine of this number. And if this is a unit circle, I should have said it the other way. If this is a unit circle, then we're looking for the cosine and the sine of this number. And that's going to be the same as the cosine or the sine of this angle because we're on a unit circle. Okay. All right, so let's think about these special right triangles. And I did them in this orientation on purpose so you could see how they fit inside the triangle in a minute. I tried to get the size right too. Okay, so label the ratios of the sides. This one is 1, 2, square root of 3. And then make sure you get it in the right spot. Okay, the square root of 3 should be opposite the 60 degrees. All right. Uh-oh, don't want that to move. Okay, so now here's what I want you to do. I want you to think about how this unit circle gets built. Okay, so I'm going to take my red pen and I'm going to drop a perpendicular to the x-axis right here. All right. And then what is going to go right here would be the length of this line segment. Right? And what would go right there in the second spot would be the vertical length, the vertical spot here, the y coordinate of this point. Okay? All right, so what we need to think about is how this triangle that I put in here, see how that's pi over 6? That triangle is a 30. This is 30. This is 60. And this is 90. It is a 30, 60, 90 right triangle. Okay. All right. Now, when I sandwich it in like I did, okay, 1 is actually the length of the radius all the way to there. Okay. So this is actually 1. And so you see, if I want to adjust the ratios, if instead of being 2 on that side, it's really just a 1, then what I can do, since the sides are proportional, is I can just divide by 2 everywhere. Okay, so if this is really 1, then I can just divide by 2 everywhere. All right, now when you're looking at this picture, see how now that triangle right there is actually this triangle just inside the circle. And so the x coordinate would be the length of this piece of the triangle, and that would be square root of 3 over 2. And then the y piece, the vertical height, should be this part, so that would be 1/2. Okay. And it turns out, what the reason we're doing this is the square root of 3 over 2 turns out to be the cosine of the angle, or the cosine of the real number representing the length of the arc. And the 1/2, that is the sine of 30 degrees, the sine of pi over 6, or you could think of it as the sine of this real number, which is pi over 6 as well, okay? Because this is a unit circle, so the length of that arc and the measure of the angle in radians are equal. Okay, so we're going to do that in the first quadrant for all of these. So drop your perpendicular. Okay, now this is a 45, 45, 90. So the radius of the triangle we know is 1. So that means instead of having a square root of 2, I need that to be 1. So I'm going to divide everywhere by square root of 2 to make that happen. And then you see how we're getting the square root of 2 over 2. Okay, for the other two sides. And so that means, let me erase that one. That one was the radius. That means from here to that horizontal segment that's part of the 45, 45, 90 triangle, the horizontal component is square root of 2 over 2, and so is this vertical component. And so we'll label those square root of 2 over 2. And that's actually the cosine and the sine of a 45-degree angle, or a pi over 4 angle, or the number that represents the length of that arc, which would be pi over 4 radians. All right, let's do one more. Let me change colors so it's not getting so connected. Let me do a green. So let's drop the perpendicular here. Okay. The radius of the circle is 1. Now this is the triangle you really should look at as being superimposed in there. Let me erase off some of these marks that went with the other part. Then that means this piece of the triangle would be 1/2, and this piece of the triangle would be the square root of 3 over 2, wouldn't it? So that means the x coordinate should be 1/2, and the y coordinate should be square root of 3 over 2. So that's the first thing I wanted you to do, is to think about the special right triangles being superimposed into the unit circle for these first quadrant angles. Okay, let me change the color on this guy here, get it erased, so that one's blue. Okay, this one I want to be blue. Okay. And then the 45 is red, and then the 60 degrees is green. Okay. All right, now I'm going to also erase here so I have a little more room at the top. And I don't know that I can get it to space like I want it to, so I'm just going to erase these and make them a little shorter. Okay. All right, so let me get the one over here back on. Sorry, let me just clean this up a second. So this one was, the short piece was 1/2, and the y coordinate was the longer, and that was square root of 3 over 2. Okay. All right, so now we're ready. Okay, now the rest of this is way easier. Okay, here's how you develop the rest of it. I want you to notice how this spot, I'm going to do in green the ones that are all going to have the same reference angle. So this angle, the 120, would have the same reference angle as the 60, because the angle formed from that terminal side to the x-axis would be the same as this angle. Do you see that? All right, and then here's another one that would have the same reference angle, because here's the reference angle that would be 60. Here's another one that would have a reference angle of 60. So those 4 that I did in green right there are going to all have the same number parts for sine and cosine, because all 4 of those have the same reference angle. They would all have a reference angle of 60 degrees. So that means you know on all of these what the coordinates of the point should be, pretty much. Okay, let me make that a little smaller and move it over just a little bit. So I know I'm going to have a 1/2 and a square root of 3 over 2, but I have to look at where I'm located to know whether I need to put a negative on either of those. So when I'm looking at being over here in the second quadrant, do you see how in order to get to that point, I would have to go left and then up? This would be negative and this would be positive. So I need a negative, don't I, on the x coordinate. But you see how the number parts would be the same? All right, this one down here. I know it's going to be 1/2 and square root of 3 over 2. And then I'm just looking at how I had to go to the left and down, so that should be negative, negative. Over here, I already know it should be 1/2 and square root of 3 over 2. And it would be a positive x and a negative y. So that's how I can complete, that's how the rest of the unit circle is developed, okay? All right, let's do the red ones next. The red ones are the ones that have 45 degree reference angles. So 45 degrees itself, this guy here, and this guy here. So that means all of those should have a square root of 2 over 2. I didn't mean to write a 3. That's supposed to be a 2. Square root of 2 over 2 for both coordinates. I'm going to go back and put positives and negatives on them, but let me get that on there. That's because All of these have a 45-degree reference angle right here. Okay. See that? And so that means the number parts for all the trig values should be the same. All you got to do is put a negative on some of them. So let me do that first. Now let's look at this one. If I were doing cosine, I'd have to go to the left and then up. See how all the points that are on the circle in the second quadrant are going to have to be negative, positive? All the points in the third quadrant, they're going to have to be negative, negative. And all the points on the circle in the fourth quadrant are going to have to be positive, negative. Okay. All right, now let's do the blue ones. Now the blue ones kind of overlap with the green ones. Okay, so I'm going to put a circle around the outside on some of them. All right, so here's one blue one. Here's another blue one. Oh, actually, let me not say that. That's true in a way, but I'm not going to develop it that way. Here's another blue one. Here's another blue one. So these are all the angles where the reference angle is just 30. See it? And since all four of those have the same reference angle, that means the number part, that means the x coordinate and the y coordinate, the lengths of those pieces are going to be the same. So you're going to have square root of 3 over 2 for the x. You're going to have a 1/2 for the y on all of these. Okay. So the same as what you had over there, because see, the x coordinate on all of these is going to be the same length if I drew in those triangles. See how the x coordinate is going to be the same length and the y coordinate is going to be the same. They have the same reference angle. They're going to have the same sine and cosine, which is another way to look at it. All we have to do is go back in and make sure we have the correct SIGN on these. So in the second quadrant, aren't we going to have to be negative, then positive? In the third quadrant, they're both negative. And then in the fourth quadrant, you have to go to the right and then down. So that would be positive and then negative. Okay, so that's how you can develop, that's how the unit circle is developed. But the importance of it is that if you have the coordinates of these points and you're on a unit circle, so it has a radius of 1, then if sine is supposed to be y over r, well, the radius is 1, the sine is just going to be y, and that's going to be the y coordinates of all of these ordered pairs. You already have the sine right there on all of them. You see that? And then the cosine would be the x coordinate of all of these points. So the unit circle is real handy, okay? And we just develop it by using the special right triangles together with an understanding of reference angles. All right, now I want to do one more. I'm going to do these in black. Let's look at the quadrantal angles and get the coordinates of the points here. Okay, well, we're on a unit circle. So these, we don't have to do anything too fancy. We just have to think about how this would be 1, 0. You went to the right 1, but then didn't go up or down. These you have to be able to do this. Okay, here, wouldn't this point be 0, 1? This point would be to the left 1, 0. So -1, but then you didn't go up or down. This one would be 0. You don't go right or left, but then you go down 1. And so it turns out that when you're at 0 degrees, your cosine is 1. When you're at 0 degrees, your sine is 0. Let's say you're here. The cosine of 270 would be 0. The sine of 270 would be -1. Okay, so there we've developed the unit circle. Okay. All right, this one's getting kind of long, but I want to do 2 more problems. Okay, and so I want to look at what if we had a point on the unit circle corresponding to t, and the coordinates were negative square root of 3 over 2, 1/2. And you were being asked to find all the other trig functions, okay? All right, what you want to do is think about, well, you can do this, You can do this really a couple of ways. You don't really have to go back and figure out what the angle was, actually. If you just need all the trig functions of that, you need the sine of t, the cosine of t, and the tangent of t. Let's do those first. And you already have the sine of t, because these were the coordinates, okay, of the point, and you're on a unit circle, and so the sine should be the y-coordinate, the cosine should be the x-coordinate. Now, tangent of t, one of the identities that we had earlier was a quotient identity that told us that tangent is the same as sine over cosine. So that might be a good thing to use to get the tangent. And so that would wind up being 1/2 over negative square root of 3 over 2. And then that's a complex fraction with the same denominator on the top and bottom. So let's multiply by 2. And we wind up with the tangent being 1 over the negative square root of 3. So that's going to be a negative square root of 3 over 3. Okay. Now you could realize that this came from a special right triangle. You could go back and think about the triangle itself and then look at the tangent from there. But this is kind of the intent of what they expected you to do. All right, now if we needed cosecant of t, we would just flip 1/2 over, so that would be 2. If we needed the secant of t, that's the reciprocal of cosine, so that would be negative 2 over the square root of 3, and we would rationalize it. And then if we needed cotangent t, that would be the reciprocal of tangent. I would do it from there. So that's going to be negative square root of 3 over 1, or just negative square root of 3. Okay. All right, and then this one says use the unit circle to find the values of the trig function at t equals pi over 2. And it's okay to think about that as an angle, but really they're talking about it being this length. But it's okay to think about that as the angle on this unit circle, okay? So you're here, in other words, here's where t is located, and that would have some coordinates. So you think about the coordinates of that point. It would be 0, 1. So then you can sit there and do sine of pi over 2, cosine pi over 2, and tangent by just thinking about that ordered pair, 0, 1. So sine is the y-coordinate, cosine's the x-coordinate, tangent is sine over cosine, which is undefined. Okay, and then cosecant is related to sine. It's the reciprocal of 1, which is 1 over 1. That's still 1. Secant is the reciprocal of this, which would be reciprocal of 0, which would be 1 over 0, which is undefined. And then cotangent is the reciprocal of tangent. So that would equal 0 over 1. So that equals 0, really. Okay. And there you have it. All right. So work hard on this homework and really do it the right way. Really think about it. And like I said, allow yourself to make mistakes on the homework so you know what you understand and don't understand. Okay? And when it says don't use a calculator, use reference angles, make sure you understand how to draw the picture and think